All right, now we're recording. Welcome to the first lesson of the course Biotechnology and the Environment. I am Nathan Bowden, obviously your instructor. If you didn't know that, then you shouldn't be too surprised. This lesson is titled Introduction to Biobased Technology, and we will be exploring the definition of the biobased technology and what biomass is, what you can do with biomass, and why. Why do we want to do this at all? We'll be learning in this lesson some general, like I said, the general topics, getting to know some basic concepts, know how to apply the definitions for bio-based economy and biorefineries, know the types of products and their value on the F ladder. It sounds very odd, but it's also called the bio-based pyramid, and an introduction to several biorefinery examples. So these will be further elaborated in lectures hereafter. So today's the kickoff. I'll introduce some concepts, and in the next 3 lessons I'll be explaining in more detail each of these concepts. Yeah. So, and I should mention that with this has been developed between Avans University and Wageningen University. So I want to give absolute credit to Marieke Browns, who's also my supervisor, by the way, and she's been incredible. A lot of these slides come directly from her, and I'm indebted to her for this. So, mad shout outs. Exactly. This is this sheet is, for example, from Marieke Browns. So, bio-based and biorefinery. A few definitions. Okay, so the definition example was the Biobased from a Latin American workshop in 2012, and in this workshop they had the theme of biotechnology, products and processes, biorefinery and bioenergy, sustainable use of biodiversity, and ecological intensification. So this is where the bio-based economy is and bio-based research is really an exploding field. It's only been around for a couple of years. So this is my question. I'm going to pose a question to you. Here we see there's a blog of live butterflies. So in this company, what they do is they produce butterflies, which you can then so that you can then rent or buy for your wedding, and then you get married and they release butterflies. So my question is now to you. This exists. Yeah, I know some of you find it slightly amusing, but it really does exist, and it's quite popular. Beautiful butterflies. So the question now is to you. Do you think this is part of the bio-based economy? The question is, do they recapture them? I don't think so. Although they just release them. All things die. I almost said Game of Thrones, all men must die, but I didn't. I refrained. It's a Christian. You say it's not part of the bio-based economy. Yeah. Well, I mean, some people would argue that it is bio-based economy. It's bio-based. I mean, the butterflies are bio-based, and it has an economic component to it. Yeah. But if we use this example, then baking bread is the bio-based economy because bread is made with yeast. Beer production is the bio-based economy because, again, they use yeast. So bio-based economy and building a bio-based society, it has a few distinctions, and this comes directly from this conference. And this is their definition. It's the definition of a bio-based economy is a technological development that leads to a significant replacement of fossil fuels by biomass in the production of pharmaceuticals, chemicals, materials, transportation, fuels, electricity, and heat. Yeah, so I'm going to rephrase this in slightly easier words. You have to use a biomass. This can be anything that is a derivative from biological production, from grass, from mowing your lawns, to chicken feathers, from chicken production, to the hoofs of cows after they've been, been sent to the abattoir for their meat. So any biomass, and almost at this time people are focusing on waste streams, so biomass waste streams that can be used to make pharmaceuticals, chemicals, etc., fuels, electricity, which will replace a fossil fuel. Yeah? Examples, we're having lots of examples, but can anybody think of an example for me? So this releasing of butterflies is not an example of a bio-based economy. Can you think of anything else? Certainly some SET students should be able to think of something. You've had projects on these. So Kaiva mentioned something. She said her example was use of waste from beer brewing to produce methane. Is that right, Kaiva? Yeah. Correct. Ding, ding, ding. Sorry, I'm trying to turn off my phone and it's not working. This is an example of a bio-based solution. So there is a waste supply from beer brewing. You can add certain microorganisms which will then produce methane gas, and this methane gas, it is a fuel. You can use it to produce electricity and heat. So absolutely, that is one example. Thank you, Kyla. So why? Why do we want to go to the bio-based economy? What's the stimulus? There is a shortage of inexpensive oil. Even though very recently there's been a slight dip in the price of oil, but this is only a slight dip. If you look at in the last 20, 30 years, the price of oil has steadily increased. Energy prices are also increasing. The security of our energy supply is sometimes up to debate. If you are a small country and you are dependent on a very large country for your energy supply, like fossil fuels, oil, then you may want to think about another source for your energy, rather than an example, the Netherlands and Russia, right? So I think that the most gas that the Netherlands buys comes from Russia, and now the Netherlands is exploring new avenues of getting their energy. This includes sometimes building their own, but finding other ways of getting it. Climate change is also a very good driver for using the bio-based economy. If you're not using fossil fuels, then you can find a sustainable way of producing your energy, and greenhouse gases will decline. Rural developments. So, I'm sorry, Christian, you're correct. They have natural gas. The question is from Christian. Doesn't the Netherlands have a lot of their own natural gas? That's correct, but it's not infinite, and it can only be used for some things. You can't, for example, refuel a tanker using natural gas. You need diesel, and again, almost all freight transport takes place using diesel. While you can use natural gas for cars, the market for that is very small. So if you can think of a bio-based way of making diesel, it's just called biodiesel, then that would be a bio-based economy solution. Okay, so back to here. Rural developments. So we want to create a stable rural society. Developing countries, they often have to import a lot of their energy, and geopolitical conditions. Again, um, there's at this time, maybe you're watching this from in the future, and you may not have heard of it, but there is a small geopolitical discussion between the Netherlands and Russia about a certain airplane that was shot out of the sky over Ukraine, and whose responsibility that was. So there are a lot of geopolitical, not just the Netherlands and Russia, but lots of countries in Saudi Arabia, etc., where people are thinking maybe we don't want to be buying from them and be so dependent on them. That's really a political priority for many countries. I know for the United States and the Netherlands, for example. Okay, so now that we've defined this definition of biorefineries, there were 7 components. This is at another conference. This is the second conference, the IEA Bioenergy Conference. The Europeans, they came up with 7 individual components for a biorefinery. First, it must be sustainable. It must maximize the economics. So, of course, you want profit. You're not doing this just to save the world. Of course, that's always something to consider. But you also want it has to be economically feasible, socially acceptable, and optimal environmental performance. The processing, it must be upstream processing, meaning it doesn't have to go very far down the line to be processed. So if the biomass is in the Netherlands, it should be processed in the Netherlands. Yes, that's called upstream processing. It must be transformational, so just pressing something together, a mechanical process, is not enough. It must be transformed from its original mass. Fractionation is a key. Thermochemical and biochemical conversions, extraction, separation, and eventually downstream processes. So this process can have actually several steps and have products in between. The biomass that was defined to be used are residues, crops, or algae. Residues just basically means waste. Crops, for example, different oils coming from seeds, like soya, for example, and algae. The spectrum is a multiple product outlet. We'll be going through the biomass pyramid, which is also called the F ladder, and talking about what these spectrum of products are. It must be marketable. So while some researchers focus on small-scale biorefineries, it must be produced at a volume enough to be consumed. Yeah, it's not just a local soap maker, for example. It has to be industrial level. The bio-based products include, as you see, a couple of the F's showing up: food, feed, chemicals, materials, and bioenergy, fuels, power, and heat. So here in Avans University, we have 2 lectorates, which are research organizations, and they are divided between bio-based products and bioenergy. So the different projects are loosely grouped into 2 different. I just talked a whole bunch. Are there any questions? Can I? Anyone want to type something? No? Wow. So everybody understood that. Well, that's good. We'll move on. Okay, so what is a biorefinery? And here you see, as in the picture, it can be compared to a prism. Yeah. So biorefining is a sustainable processing of biomass into a spectrum of bio-based products and bioenergy. So as you see here on the one side, the biomass goes into the biorefinery. Here it's in the shape of a prism. And the biorefinery splits this biomass into its valuable components. and we often talk about the value chain. And these components can be either related to, in the case of bioenergy, heat, power, fuels, and chemicals. Although I would say the chemicals actually are a product, so this should be underneath the rainbow, but that's a small point. Food, feed, and materials. And these four are products, and these three are the energy. Yeah. And so you may only start off with one biomass, like I said, soy or chicken feathers or anything, cow hooves. After this biorefinery process, it can be divided into several different products. Yeah, so trying to extract, extrude, transform into the highest value possible. So, a normal refinery, petroleum goes in, and then you have two splits, either fuels and energy, and chemistry. So you may not know, but you can make a lot with petroleum, not just petrol that you put in your car, but also lots of pharmaceuticals, plastics. All of these are made, not all of them now, of course, nowadays we have bioplastics, but by and large, most plastics and an awful lot of pharmaceuticals are made from petroleum. So anything that you smear on your skin, it has a petroleum product in it. What we want to move towards, and then where there's an awful lot of research going on right now, is converting a biomass, so these chicken feathers, these soybeans, these leaves, this grass, converting them into bioethanol, biodiesel, biogas, like methane, hydrogen, or into the chemistry, the basic and fine chemicals, biopolymers, and bioplastics. Some people would say this is a radical change, but to me it's not. To me it's just making use of products that we have already that we are not using correctly to their full extent, and that can replace petroleum. So now we're going to go into further and further detail. We've talked about the very theoretical parts, but now what does this mean? So let's, for example, here you have some raw materials. You have corn, you have leaves from a plant that you may not use the leaves for, or you have a tuber, which is like a potato. These can be put into a biorefinery. Sorry for the small typo, that should be an E in biorefinery. There will be an intermediate step, followed by some other processes, and developed into, for example, plastics, nylon, polylactate, biodiesels, and bioelectricity. Oh, sorry, Christian. Oh no, it's not a radical niche. Some people consider this a radical switch from using petroleum to biomass. To me, it's not. To me, it's just we're using a different source product. But the chemistry, if you start getting into the chemistry part, it's not so different. You just have to somehow process these raw materials into their basic components, and this can be done, and that's where my research, for example, is. And actually, your research this period also, the next project. Okay. So its content was biorefinery. We talked about the definition of biorefinery, biomass source. A biomass source is like the potatoes or the chicken feathers. Typical products, bioplastics, biodiesel, etc. So the examples is potato to starch and protein, also to biofuels. Another important component of biorefinery is the chain, the logistics chain, but also the conversion chain. Yeah. So what we need to look at when considering different biomasses for conversion, we have a whole bunch of different types. And this is partially what you will be doing. You have cassava. If you don't know that, it's a tuber. I think I'm originally from from Africa, but it's also used a lot in South America. Grasses, lucerne, maize, oil palm, which is a very large product in Southeast Asia, potatoes, rapeseed, which is very common in Europe, sorghum, soya beans, sugar beets, again a very European product, sugarcane, which is more South American, but also Southeast Asia, sunflower, a European product, switchgrass, tobacco, wheat, and willow tree. These are just a few of the many products that you can use. But when you're evaluating a biomass, which you will be doing in your projects, is to look first at how much is produced. It has to be an industrial level. So you need to have, these are the levels that are set. If you can produce 10 tons per hectare annually in dry weight, then you're doing well. So who can tell me which two in this example are no longer good choices? Sunflower? Yeah? There's one more. Willow tree, good Christian. Correct. So if you look at the dark green, this is the wet weight. Remember, when you get cassava or grass or any of these products, when you get them, their yield is wet. But when you want to do any kind of conversion to them, of course you only use the dry, you can't use the water. So in the case of sunflowers and willow trees, their annual dry weight in tons per hectare is just too low. It's under 10 tons per hectare. So even if you had a huge sunflower field, it still would not yield enough. It would not use the land properly. We need to, get the most out of what we have. Now, if you can get up to 20 tons of mass, dry mass per hectare per year, and the A is for annual, by the way, then that's great. So which ones now fall off? Someone other than Christian. Okay, Christian, you can say it too. Soybean, correct. So soybean is classified as good, 10, but not great. So its dry mass is above 10, but it's well under 20. What other do we see that will be in between? Yeah, yeah, yeah. Very good, Christian. So yeah, so the grass, the lucerne, the potato, and the rapeseed, they all are between 10 and 20. So they're good, but not great. And then, of course, above that, above 30, is then the fantastic. You can get more than 30, and so what in this figure do we see as fantastic biomasses for conversion? If you guys, yeah, so we have people who are talking, but just type it in. Okay. So, what did you say? So you said maize, sorghum, cassava, sugarcane. Yeah. How well do you think maize, cassava, sorghum, and sugarcane grows in the Netherlands? Very poorly. Yeah, very poorly. So this is the second consider. Yeah, exactly. Not well. Thank you, Natalia. You're absolutely correct. So while it's very logical, we should, if you look at this, you say, well, we should just plant sugarcane everywhere in the Netherlands. Sugarcane, however, does not grow very well in the Netherlands. It's no, there's not enough sun. Yeah, sugarcane is a fantastic crop. It grows wild, grows like mad. Unfortunately, it needs very, very warm and very warm conditions, a lot of water, which Netherlands has, but it's not very warm, and also it needs a lot of sun. So when you guys will be considering your product that you would like to advance, then you have to take that into consideration. So you'll be looking at this kind of data, and logically you say, well, sugarcane, but not so logical because I'm going to ask you to pick a country. I guess you could pick, if you pick Brazil, then you can do that, or South Africa. Um, then you could. But if you would like to look in like the Netherlands, you have to think about what grows here. So, as I mentioned, that's why I mentioned it when I was going in my list. I mentioned a few of them and where they are. So let's see, grass. We have lots of grass in the Netherlands. Corn, it doesn't grow so well, but it does grow, but not to be eating. That's the other thing. Corn does grow in the Netherlands, but very little of it can be eaten. The species that grow here are not the best ones to eat as humans. Huh? Both corn species, yeah. So the oil palm again does not grow here. Potato, well, the potato would possibly be one you'd think about. I believe the rapeseed does also grows here in the Netherlands. Sorghum not so much. Soybean is very difficult. The sugar beets, that's one of the one of the best products the Netherlands has. Sugar beets grow very well in the Netherlands. And then sugarcane, not so much. Sunflower grow, but not the best for the capacity. Switchgrass grows, wheat grows. So your groups will, as part of your work, will be analyzing which of these products will be best for your location. And also, I recommend choosing a European. I'm saying this now. I highly recommend choosing a European location because of just data. If you choose the Netherlands, Germany, France, I'm not sure about France, Belgium, you can download so much European data at a very detailed level. Europe in general, they have everywhere, including Romania, Spain, but at a less detailed level for most of these crops. Yeah. So your best bet will be the Netherlands because we have so much data. But any European country, I can guarantee you'll have at least enough data to do your work. But if you say, for example, I want to do a Brazilian case study, then I cannot. Maybe there is lots of data. That's maybe the case, but since I don't speak Brazilian, I haven't been to these websites to find it. But, so you're on your own if you choose Brazil. I assume also the United States there must be lots and lots of information. I'm sure. I just haven't done it myself. It's up to you. Okay, so here are these same plants. We talked about the dry weight versus the wet weight, but the constituents are what we're after. So this cassava, of the dry weight, yeah, about 38% is simple carbohydrates. Another looks like to me 30% is complex carbohydrates. 10% is lignin, maybe 8 to 10% is protein, and there's a very, very little bit of fat. Now, this is what makes it more difficult. So I said 3 or 4 products can be found in the Netherlands as good products for a bio-based refinery. But I can tell you now, fat has a higher market value. And you can actually, not only it has, well, not very high market value, it's just that it costs very little to get fat from palm. You just have to press it. Getting the protein out will cost more, but the protein will have a higher value. Lignin, well, what can you make from lignin? So you have to analyze each of these products, say which one and where, because they're all very different. The sunflower, it may have a very low dry mass, but it has a huge amount of fat, sunflower oil. And it actually has, for a plant, a very high protein level. And proteins are can be extremely lucrative. So you have to not only analyze how much dry mass, but also what does each dry mass deliver economically. Yeah? So here are a lot of the typical considerations for this biomass. What's the cost per dry matter ton? The yield, the composition. I would say these two are probably the most interesting. Transport properties or transport costs, storage properties, seasonality. Sugar cane, for example, in Brazil it grows all year round. They have 3 or 4 cultivations a year. But sugar beets only once a year. It's only active about 4 months a year. Processability, the value of the product, genetic improvements, how to have a production chain, geographic region, and the agronomic considerations. Now, for your projects, you will not have to do all of this. It's way too much for a 6-week project. But definitely yield, composition, seasonality, value of products. These are the things that you will be considering, and of course, geographic regionality. And this is what you can start off when you're doing your analyses. And I'm going to let you guys, this is where I give you a little bit of self-activity, and I take a short break. I would like you to think about, you don't have to go into great detail, think about 4 biomasses, yeah? And just using your, and use a Dutch expression, your farmer's logic, just to use your basic, you guys are intelligent people, so use your basic knowledge, and give a plus or a minus for all 4 of these along the line. So wood, the composition of wood, do you think that's makes a good candidate or a bad candidate? Is there a lot of oil in wood, or is a lot of lignin? Cost per ton, how much does it cost to produce wood? The value of the products that you can make from wood. Can you genetically improve a tree to produce more of the product that you want? Or to make it produce more. You can make a faster tree, a tree that grows faster, a tree that has more leaves, a tree that, these are basic things. A tree on steroids. Storage, how easily is it to store wood? I'll give you a hint, it's pretty easy to store wood. And the transport costs per ton, let's say. Okay, I'm going to give you guys 10 minutes to think about it, and when we come back, we'll continue. And I've already filled this in, so we'll see how close your ideas come to how I filled it in. All right, welcome back. I hope I gave you enough time to at least do one of the lines, one of the rows here, and I'll reveal what I filled in. Yeah. Also, I used like a plus minus scale. So To me, wood is the composition of wood. To me, is not very good. And if you go into detail, you see that wood is a lot of lignin. Yeah. So wood does not have a lot of the higher component materials. So it's good for fuels, but not so much for products. Costs. Wood it's pretty cheap, especially per ton. When you look at the amount of transport, you can easily stack it, you can easily transport it. The costs are actually quite good. The value of the products, however, not so much. It's pretty difficult to improve wood. It's possible, of course, some wood grows extremely fast. Pine trees, for example, grow quite fast. But to improve them is difficult, and research takes a very long time. Storage is excellent, and the transport costs are also excellent. So that's just for wood. I will let you think about the rest. For time, I'm going to skip the rest, but each one has its own positives and negatives. Okay, can we cope with negative values? The answer is yes. The composition, we can genetically alter grasses to produce more lignin. We can genetically produce algae that grow faster, etc. Yield, we can have different techniques. Agronomy, the science of agriculture, is dedicated to this, improving yield. Costs, certainly we can think about fertilizers, chemicals, where we plant it, the costs of harvesting it, so new technologies, and also genetics. Storage, think about ways that you can improve the storage of these biomass, and also transport, dewatering. So if you can dewater or desiccate the biomass before transportation, you will dramatically lower the costs. So if, for example, I forget which one it was, at a very high percentage of water, if you can get rid of the water, well, then you can transport more dry mass at a much lower price. But these are then, when you, in your project, you'll have to think about this. These will be your advice. Yeah, this is your advice section of your project. So, grass. Is there a few products or many? So if you go back to the earlier presentation, and again, of course, this presentation is on the Blackboard side. Grass, if you look up, costs about 60 euros per ton. It's not too expensive. And it can be, let's see, it has 30% fiber, 50% protein, and 50% juice or water. And these can be sold onward. So the fiber from the grass, you can sell for 30 euros a ton. And you may be surprised, but yes, you can actually sell grass fibers. Proteins, well, they obviously are worth a lot more, at about 120 euros per ton. And the juice is 55 euros per ton. That means a total per ton of 205 euros. It may seem like you've gone from 60 euros to 205. That sounds pretty good. But we have not taken into consideration the production, how much the production costs. And I'll tell you, it does not look good. But here's the crux. That's not all you can do. That's why the bio-based economy has a lot to do with technologies and chemistry, because we can break fiber and protein down. Yeah. So fiber, what is in that fiber? Protein. What's in the protein? This protein, which a basic protein has a worth of 120 euros per ton, but there are different types of protein in grass. Just like in your body, you have lots of different types of protein. Grass is the same. It has different types. Rubisco, which has 5%, is worth 8,000, or in other words, 400 euros per ton, just for that one protein. The average proteins are 80. Saccharides, for example, are worth 9 euros per ton. We've forgotten the amino acids. amino acids. So was where my research is. There are several amino acids that you can get from grass juices, and they together are, I think this is 60, 70, 150. That's about 200 euros just on these amino acids. Organic acids can also be divided between different types of organic acids. The general organic acids are only worth 60, but if you were to be able to separate them through a technology, they would be worth significantly more, 120 if I add that correctly in my head very quickly. So in the previous slide, we had about 600 euros per ton, but if we separate these basic components into more higher valued components, it's now worth 1,200 euros per ton. And that is a significant added value. Yeah, so I'll skip back one. Originally, the grass costs 60 euros per ton, and eventually, if we develop the techniques, you can get 1,271 euros per ton, which is a very high added value. And now we have the F ladder, which is also called the bio-based pyramid. It's both things. On the left, we have the bio-based pyramid, and its parallel its F ladder. So at the bottom of the bio-based pyramid, we have energy. Yeah. So energy, you need the most volume for it, but it has the least added value. So wood has fibers. What can you do with wood? I mean, burn it, of course. Burn it to get energy or heat. But you need an awful lot of wood, and that heat and that energy has a very low value. As you go upward on the pyramid, performance chemicals, fermentation, commodity chemicals, so these things are like ethanol, yeah? You need less volume, and it produces more added value. It's not fantastic, but it's getting somewhere. Above that is alimentation. That's food and feed. So this could be food for humans or feed for animals. That's basically the difference between food and feed. Food is for humans and feed is for animals. And at the very highest, you need the smallest amount of volume, has the highest added value. These are pharmaceuticals and fine chemicals. And yeah, so this is where lots of research is going towards, including my research, looking at the basic chemistries of biomass and how to produce high value products, but with low volume. Parallel to this is the F ladder, which some people refer to. The top of the F ladder, yeah, pharma is normally spelled with a PH. For our uses, we want to make it with an F, because otherwise the F ladder doesn't work. So pharma is at the top. Then fun. These are the things that make the most money. Food and feed make a lot of money. Fiber and fermentation. These are lots of products like ethanol, bioethanol, fuel, biodiesel, fertilizer. So just conversion of things like lignins to fertilizer. Fire and fill. These are energy. Yeah. So sometimes people refer to the F ladder, sometimes they also refer to the bio-based pyramid, and you should be able to explain that in your projects. So here are some typical products. I won't go into too much details, but fuel or bio oils, ethanols, biogas. Yeah, that's dried digestive grains and solids. Yeah, so that's DDGS. So these are dried grains and other. Yeah, so the example that you, Kaiva, the example that you had at the beginning of the class of the dregs from the beer production, that is a DDGS because it's a dried grain. You used wheat to make, for example, wheat to make or hops to make your beer. And when it's done using it, you dry it, and that's a DDGS. Yeah, that's a grain. Foods, starches, sugars, paper, polylactic acid, that's a polymer, or chemicals like lactic acid and glycerol. Yeah. And how do you make these processes? Some of them are mechanical, some of them are through fermentation, and some of them are through chemistry. And here are some examples of that. There's a few more slides, getting towards the end. Biorefinery is part of a chain, and definitely in your homework, which you'll be doing for assignment 1, that will be hopefully very well explained. There's a website you'll be using. It's very much a chain. So it's not only replacing oil refinery, you have to take the entire chain into account. New chains need to be developed, existing ones need to be modified, and of course there's logistics. And these are the common themes on bio-based research in the last few years and for the coming decades, I'm sure. So, what is your assignment? This is your last sheet. Actually, there's one more slide, but here's a link here. It is a website that was developed by Wageningen University. It was given to them by the Ministry of Economic Affairs. And what they have is, I invite you to go to the website. It is a chain. Here's a screenshot of one. Where on the upper left corners, far upper left corners, you have the biomass types, and the bottom right side, you have the products. And you can explore for each biomass type the different pathways to the product. Yeah, it's very visual, it's very interpretive. I must say also it can be done in English or in Dutch. So if you by accident are on an English side and you want the Dutch, if you're on a Dutch side and you want the English, just click on the upper right hand corner to switch the language. The link here should be English, but if in the future you accidentally stumble onto the wrong language, you can always switch back to English or Dutch, whichever you prefer. And so now would be time for Christina's question. Christina, you had a question. I'm going to welcome back. One more slide, unless you've played around a little bit with the website. And this is about next lecture. Yeah. So next lecture will the outcome will be that you will know the main components, the building blocks of plant material. So I will really quickly through fibers, proteins. What does that all mean? You know. Next lecture we'll be talking about that. Yeah. We'll be talking about properties of these components, in which biomasses these components are mainly present in, and also being able to, in between air quotes, read the biorefinery naming. And this will then continue in lecture 3. So thank you for your attention. I will be here. How much time do we have left in this class? 5 minutes. So I'll be here for 5 more minutes, and I will see you again on Friday.